Mm-hmm. Yeah, it's probably better if you're like out there, honestly, because yeah, the delay is annoying. How'd it go, Mike? Oh yeah, yeah, that's how it always is. More time. Just wait till we have to compress like 3 lessons into like 20 minutes tomorrow because of all the time we lost.
It was just, you know, it was just hard because it was the like anyone questions, you have to go backtrack. Stop for 10, 15 seconds. That was fun.
It's rough, man. It's rough. Not long. I'm about to start now. Well, wait, but you're in Echo, right, or Foxtrot? You're going back with Nate. Yeah. So see what he was doing. I think he's gonna kick y'all off on some exercises. You want Turing network? Yeah, you can sit. Yeah, just come sit in here. Maybe the network's better in here. Oh, shit. All right. Let's get going here. We're gonna see what we can do. Let's see. How's my sound? Okay, good. Sound gone. Good. It's broadcasting. Okay. I don't know about full screen. I don't know about any of this, so that's unfortunate. But oh, look at this. We got a whiteboard. We got some programming to learn. We got some snow outside. It's a good day. So this morning we're going to talk about flow control. And when we say like flow control, when we say that term in the context of programming, what we're really talking about is what order will, well, I'd say in what order will Ruby evaluate my code? So I've got some lines of code. One, two, three, four, etc. And we want to think about and have, particularly want to have start to build up our mental model of how Ruby is going to handle these kind of things. And the first question to ask is, what is the basic model? Basic model for flow control. What are the basic rules? Yeah, we're gonna try something here and see how this works. So Ling, I've got some code up on my screen. When I have these lines of code, in what order is Ruby going to evaluate these 6 statements here, these 6 expressions? And now I'll pause because I know you have the delay. Yes, this 15-second delay is amazing. Oh, Patrick, you're not Ling? Is it really bad? Is the resolution? Oh, damn it. All right, we'll let Ling off the hook here. Cool, there we go. Basic model, right? It'll do 1, then it'll do 2, then it'll do da 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 da. So the basic model we could summarize as, and this is perhaps somewhat obvious, but top to bottom, right? And that's kind of how things start out. And so when I have chunk of code like here, Ruby's going to read this code and da 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 da, and then it's going to say, okay, 1. It'll do 8 + 7. Yep, exactly. We're going to have 1. do some variable assignment, do some more variable assignment, put some stuff to the terminal, put some stuff to the terminal, put some more, do some math, put some more things, et cetera, et cetera, et cetera. And we're going to have a lesson actually in a couple weeks when we talk in a little bit more detail about what we call the call stack, which is sort of the mechanism within the Ruby interpreter that it uses to manage this process, to manage the order in which things get executed and stuff like that. But for now, what we care about is kind of just the behavior, right? The behavior that's going to go top to bottom. Now, the problem with that is if we could only write programs that evaluated code in this order, 1, 2, 3, 4, it's pretty limiting on the kind of things that you can express. We want to be able to write all kind of powerful programs. We want to be able to write flexible programs that can, in theory, accomplish anything. And so we need to have some more sophisticated flow control mechanisms. All right, so we need these things in order to be able to write powerful programs. And we'll go on a little bit of an aside here. This kind of gets into some slightly interesting like computer science stuff. You'll hear sometimes the term thrown around of a Turing machine. Or you'll sometimes hear the term something being Turing complete. And a Turing machine specifically is a conceptual model for how a computer works, and it was developed, it's named for Alan Turing, it's developed by Alan Turing probably in the 30s or something like that. And it is an abstract notion for how a computing machine might be made and the way a Turing machine works. Actually, we'll pull up some things. Turing machine. We see some pictures. Here we go. This is a funny little drawing. Turing machine is a hypothetical device that has a infinite tape of ones and zeros, and then it has a machine head that can read numbers off the tape, and based on a predefined set of instructions, it's able to move to other places in the tape or rewrite values or do all these sort of things. And what's interesting about it is that with that simple model, you're actually able to express any computational idea. So the idea behind a Turing machine is that any computation that can be done by a computer can be expressed using these simple set of instructions. And so when we talk about a language, a programming language being Turing complete, we mean that the language has built into it the mechanisms that would be necessary to express any conceivable computation. And it turns out that what's needed to make that happen are mostly this. So what we're about to talk about are sort of the ingredients in Ruby that allow it to be Turing complete, that allow it to be flexible enough to express any desirable computation that we might want to do. And so when we talk about these, there are a couple. Where's my eraser? There it is. Oh. When we're talking about flow control mechanisms, there are a couple of ones that we care about. And really, there are actually mostly two. There are really two types of flow control mechanisms that are required to be Turing complete. You need two things. So before we dive in here, I'm going to stop for a second, pausing for any questions. Give me Oh shit, I also forgot. Well, whatever, I forgot my Pomodoros. We'll Pomodoro in like 10 minutes or so. Cool. All right, so it looks like we're good. Totally confused. Oh no, Emily. All right, I'm going to go on, Emily. If you think of a question, anything in particular you want to ask about, just let me know. Cool. Okay, so where did we leave off? We said that we got a couple things that we need to care about, and the two things that we really care about are one, oh man, some fresh markers here. One, looping. We need the ability to repeat a set of instructions. And the second one is branching. We need the ability to choose between two sets of instructions. And those are really what we care about. And we're gonna look at Ruby's constructs for doing these things in a second here. And what we're gonna see is that most of them fall into this category. There are, in Ruby, we have several ways to achieve the first thing, several ways to achieve looping. We really only have one or two common ways to do this one. So we're gonna see more ways to achieve looping, but the important thing I think to keep in mind is that they're all ultimately achieving the same goal, which the goal is in abstract. We want to have some set of instructions. We want to be able to repeat those as many times as we need. So diving into that a little bit more. Actually, let me pull this back up here. In Ruby. In Ruby, what are our options for looping? What can we do? We have a few. So we'll see some examples. We have, first of all, there's the good old while or until loops. We have simply the loop keyword. And we have the number times method on fixNum. And yeah, cool. That's really the ones that we're going to see. And as a quick aside, you'll see this notation. You'll see from time to time in the context, especially of Ruby documentation, or I'll use it on the board sometimes, where you have pound sign and then word. And so what this is a notation for is indicating a method name and a class. So when we use this notation, we're saying that we're talking about the times method, the method called times on the class fixNum. So sometimes you'll see that used in different places to describe a method of a class. So we'll run through these real quick. Oops. Cool. So with while, it's pretty simple. We're going to have while some condition thing 1, thing 2, etc., and then an end. God damn. I guess I'm switching to this. And so the parts, what do we say that the point of the looping construct is? Well, we want to repeat some set of instructions. In this example, what will we be repeating? Well, whatever appears in here. And we'd refer to this as the body of the loop. And then the other thing that we care a lot about is this bit where I sort of put in placeholder here. So when we say while some condition there, we're talking about adding an expression there which evaluates to some Boolean value. When we talk about condition, we're often talking about Boolean values, and just remember to recap, when we talk about Boolean values, we're talking about true or false. And the point of this being built in is that, well, a loop is sometimes you have a scenario where you want an infinite loop, a loop that just continues indefinitely until something happens, but I mean, until you basically kill the process. But generally, we want a loop that only continues for some finite number of times. And the purpose of the while keyword taking a condition like this is that it allows us to specify when that should stop, when the loop should break out. And so real quick, I'll demo one of these. Today's notes. Oh, good question, Ashwin. The pound sign refers to the method. And so the sort of the convention is that you would write the class name, then the pound sign, then the name of the method. I'll send, and also a good question, notes are here. So real quick, just to demo what that looks like. Here, I can get rid of that. I can say while. So here's what I kind of want to avoid, right? What's the obvious sum condition I can say? I can say while false. We can put looping, and then we can put an end. And in this case, what is it going to do? Well, how does the while loop works? If the condition that you give it, if the conditional expression that you pass it is true, it'll continue to do your thing over and over. In our case, false is obviously not true, so this never actually gets executed, right? So what's the most ineffective loop is something like while false, do this thing, and then this thing is just never going to happen, right? What's the other super simplistic alternative? While true puts looping. And we can guess what's going to happen here. Perhaps the true is always true, so the while loop will just continue hitting this line over and over and over, and we'll see a flood of loopings coming out onto my terminal, which is annoying. The thing to know here, common handy trick, if you ever get stuck in an infinite loop, you want to hit Control-C to get out of there. So that's your escape hatch. So I'm going to do that now, Control-C, and we can see that it stopped. So that's kind of just the basic syntax of it. What's more common is that we want to have, what's a more common usage, obviously, is that we want to use the while loop here to do something X number of times, or until some condition is met. And so something you might see a lot of is something like I can set X is 0. I can say while X is less than 10 puts X is X, and then we can increment X by 1. And we'll see that this gets hit 10 times. X is 0, 1, 2, 3, da, 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 up to 9, right? And so what's the loop doing? Every time it's going to evaluate this. Every time it's going to evaluate this expression, and if the expression still evaluates to true, it'll do the body of the loop. It'll execute the body of the loop. So let me talk about one more thing, and then I'll take a break for some questions. So then the last one, that's kind of the basics of while. I'd say while is perhaps the most common looping structure you'll see in Ruby. A close sibling of while that you'll sometimes see. Oops, I need my board. Is until. And until is really kind of just the opposite of while. And so whereas while will execute your body as long as the expression evaluates to true, until will execute the body of the loop as long as the expression evaluates to false. So until is really like saying while not stuff. Kind of the gist of it, because remember the not operator, people have, maybe we haven't talked about this that much, but the not operator is how we negate a Boolean value. So if true is a Boolean value, we can say not true to negate it and get false, or similarly not false to negate a false and get true, since true and false are fundamentally opposites, right? And so if I wanted to say something like x equals 10, and until x is less than 0, we can say puts x is x, and we can say x minus equal. I forget what the minus equal is, but whatever, we'll do that. And we see the same thing in reverse, right? And so again, the until is like if you had a while, but instead of having a less than, you had a greater than, or if you had a while and you wrap this whole thing and you put a not sign in front of it. So until and while are just kind of conveniences for one another. People like to use them to make the code read a little bit more Englishy. So sometimes it's more convenient to say until instead of while not. So that's kind of the gist of that. And so I'm going to stop now and take some questions, and keep, once we get through, I'm going to go somewhat quickly through these because I'm trying to get you hopefully into these exercises in a few minutes. So I just want to really hit the basics for now and then get you to practice it. So any questions? Moment. Until runs until the expression is false. I think you have it backwards. I know it's like confusing but I always have to just talk it out. So until runs until the condition is true. So until runs as long as the thing is false. While runs as long as the thing is true. So quick and dirty way to test it out is I just hop over here and I say until true puts until doesn't do anything in that scenario, right? Until false puts until. You get an infinite loop. So until false is going to say until this thing is true, and false is never true, so it just continues forever. Similarly, while is the reverse. So while false won't do anything because while only runs the body when the condition is true, and false is never true. So whereas while true triggers the infinite loop. But yeah, I agree, it's kind of confusing. Until. Yeah, I think Jared is. I think until runs until the expression is true. won't run, right? Because it's already true. There's no runs because we're waiting for the thing to become true, and in our case, it already is always true, so we don't do anything. It is a little brain bending. Yeah, I like that, Patrick. It's a good way to keep in mind. Cool. All right, 10:34. Okay, I'm gonna keep on going. Keep the questions coming. I'll try to like pick them up as we go. Let's see. We got a couple minutes. We'll do a little bit more and then we'll take a break. I'm gonna skip over loop and break for a hot second just because I don't think it's quite as important as getting into the next stuff. So that kind of covers some basic looping. You'll get plenty of practice with this as we go. Another one that we want to use a lot is I mentioned this before, the fixed num times method. And fixed num times is an interesting example of it's a very Ruby-ish, Ruby sort of thing. And what I mean by that is Ruby. One of the things that we love about Ruby as a language is it tends to go out of our way to kind of make things easy. Ruby wants to make things nice and pleasant to work with. It wants to be a friendly language to use. And so that pattern that we looked at a second ago, where I said x is 0, while x is less than 20, This pattern is super common in programming because it's like, oh, I have some things and I need to do them 20 times, or I have some things I need to do them 40 times or whatever. We see this so often that Ruby comes with a very handy built-in construct for doing the same thing. And the way it works is we're going to call the times method. So we're going to call the times method on a fixed num. What is a fixed num? Well, remember, a fixed num is just a number. So say I want to do a thing 15 times. 15 dot times. Remember, the dot is calling the method there. And what I need to do here is we're going to give it what's called a block. And we're going to talk more about blocks in a concrete sense later. But the sort of executive summary is a block is just a transportable chunk of code that you can do things with. In this case, we're passing the block actually to the method. We're passing the block as an argument to the times method. And then what goes in here is something. And again, we call this the body of our block, of our loop. And what will happen here is pretty much exactly what you expect would happen. 15.times do puts hello int. We see, well, I should have used a smaller number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I counted wrong, but you'll see 15 hellos, right? So ultimately, what is going on under the hood here? Well, this is ultimately just a wrapper that Ruby gives us around the standard while until looping constructs. But it's great because, again, like we said, that pattern is so common of needing to say, like, oh, do this thing 20 times, do this thing 10 times. So we have a super easy way of doing that in Ruby. And I think you'll find in a lot of programming languages, JavaScript, for example, you'll see set I is 0 for, while I is less than do this thing. And so in Ruby, we'll tend to see this pattern more frequently, the fixed num times, more often for that kind of thing, just because, again, it reads really nicely. The other thing about Ruby, the other thing that comes out of Ruby kind of giving us these nice usable features is that it tends to make things really easy to read. It tends to read in a way that's similar to English. And so that's kind of a nice little thing as far as being able to read code. I think what we're going to do now is let's take a break until 10:43, and then we'll pick up there. We'll cover if else real quick and try to give you at least a few minutes on these exercises. We're running a little bit behind, but we'll get after it. And if you have any questions about what we've covered so far, please just drop them into Slack while we're on a break, and then I'll pick those up as we go. So see you in 5 minutes.
Yeah, I think I'm gonna walk away again with these. Yeah, but I think I'm gonna walk away again because I think this is just like a little. It's weird that we can't like, but I guess we can. I think I'm gonna walk away though. Me too. I feel like it's really distracting.
Oh man, get my headset back on here. Ready to go. All right. I'm going to get started again. Let me know if you're having any trouble hearing or anything like that. So the last thing, oh yeah, I guess I'll. Last thing that you need in your toolbox is, we talked about a couple ways to loop, a couple ways to repeat instructions, either an infinite or finite number of times. The last thing we said was that we need some way to achieve branching. And when we talk about branching in code, we're talking about really choosing between two sets of instructions, choosing between two possible paths in the code. And the obvious mechanism to achieve that is using Ruby's built-in if-else. And what are we looking for in the context of an if-else? Similar to a while, the if is going to take some condition here. And depending on whether that condition evaluates to either true or false, we'll do A or B, right? And so if our condition evaluates true, we'll hit A. Condition evaluates false, we'll hit B. And this seems maybe a little bit basic, a little primitive, and that's okay. I think it's hard to overstate just the importance of this fundamental concepts. I mean, this is ultimately how this ability to branch, to make decisions based on conditions in your code, and the ability to use loops to repeat instructions over and over is ultimately what gives you the power to make sophisticated programs, right? And ultimately, to some extent, the art of programming is just combining those fundamental constructs in different ways to express your intent. And so again, what does it look like? Pretty straightforward. I have if true, hitting the true case, else case. And we see hitting the true case. I can do the opposite if false. And we see the false. There's another interesting concept about Ruby that's worth touching on here, which is the notion of truthiness. And the reason, when we talk about, I say if some condition, it turns out that Ruby as a language is pretty permissive about what it will allow you to put here, about what it will allow you to put in the some condition place. And so an example is I could say if the string pizza Pry doesn't love it, but it does work, right? We get truthy, right? Because pizza is a truthy value. The point to make here is that in Ruby's case, we will accept things that are not necessarily literally true or false. The literal Boolean values true or false. We'll accept other values as well. And the behavior that we expect to see there is that it's pretty straightforward. Nil and false are treated as falsy. Everything else is treated as truthy. And again, what do we mean when we say falsy and truthy? We mean that when these values are used in the context of a Boolean expression, they're treated as false. Or when these values are used in the context of a Boolean expression, they're treated as true, right? And so just as another example, if 1, 2, 3 puts high, and I'll get my high, right? You can put an integer in there, you can put a string, you can put a array, if an empty array. Look at that. And so, just an important thing to keep in mind. I think this is a thing that it can be useful to exploit when you mean to do it. I think in general, it's a good rule of thumb to try to actually use as much as you can. Use actual true and false when you're dealing with conditional statements, just because it makes things a little bit easier to follow. It makes things a little bit easier to see, like, oh, okay, it's true, oh, it's false, whatever, as opposed to, oh, if some random string or if some random number, I'm going to do this thing. But it's important to keep in mind that Ruby will allow that. So that's the deal. A couple other quick pointers. We showed examples there with the if-else, using the else to evaluate some expressions when our condition holds false. It's important to note also that the else is actually optional, so I can have an if end and just go through. In the case when you don't have an else branch, there's simply nothing happens. So if false, just nothing will happen here. If I had replaced the false with true, I would get the string stuff out of that expression. But since I don't have an else, if my thing is false, then nothing happens. And to be a little bit more precise, when we say nothing happens, what we actually mean by that in the programming context is that we're going to get actually a nil. So it's important to keep in mind also that an if statement with no else will give you the result nil. Whereas if I say true, I actually get the string, it's true. I get the value that comes out of the true branch there. So true is ultimately used to, I guess the important point to make there is that an if statement ultimately does yield a value. It ultimately does generate some value that it's going to give back to you. Cool, let me see, what is this here? Let me open this up. Some things. Yep. So Ruby again is a little bit permissive a lot of times with the syntax, and in certain cases, so let's say I say x is true. If x equals true, pizza, and I get back pizza. The first thing to note is that this simply, since x already is a Boolean value. We haven't really talked about the double equal. We'll talk about that in a second. But since x is literally a Boolean value, I could actually simply here say if x pizza, because x is already what? Oh, x is true. So if true pizza, that works out as well. So you actually don't really need to compare true to itself to see, like, is it true? You can just check x as long as you know that x has true or false in it. And then, yeah, I mean, this is, I'd say, not a super important thing to hammer on right now, but the other thing here is Ruby will actually allow you to inline this by saying pizza if x, and I'll get pizza, whereas pizza if false, I'll get nil. So if you literally only have, it's just a if on one statement, you can inline it in that way. So pizza if false, pizza if x. The way, I think, Chris, the way you had it the first time would not work. Ruby's not going to love having this just hanging out here. So you'd have to inline it this way if you wanted to. But I would say for now, I mean, unless you feel really comfortable with it, I would stick with this standard style. If condition on one line, next line, indent 2 spaces, and throw your statement in there and then close it with the end. Good question though. So cool. So that's kind of what I got for now. We take a couple more minutes for questions, and then I'm going to give you like 10 minutes to crack through these exercises, and I'd expect you to at least be able to get 1 and 2 and maybe 3 here. 4 probably is a little bit longer, but let's give it a second to see if any more questions pop out. So when you say if x, you imply would you have to write a condition? Talk about string quotes maybe another time, but for now, yeah, you can just use either one. So when you say if X, you imply that it's true that there is X. Well, I think, I'm not totally sure what you're asking, but I think you're saying, like, I can't say if dog, where dog is not a variable, because I'll get here an undefined variable error, right? So you have to have X defined already if you want to use it in that way. That's true. Now if I say dog is false, if dog is a thing. And so we're saying, remember, the way to think through these, right, is you just want to imagine substituting the variable for its value. So if I write this code, well, what is dog? Okay, dog is false. So that's as if I had literally written if false, dog is a thing, and then said end. And obviously, if false, well, nothing will happen, right? So and then the question about, like, would you have an opposing condition? Well, only if you need to do something in the negative case. And so that's where it becomes kind of up to us to work through what are the conditions and what does the code need to do. Genevieve, pry, we'll talk about maybe tomorrow. Pry is basically like IRB. It has some nice syntax highlighting and a few other cool things. So we'll probably eventually get you guys on it, but for now, IRB is basically the same thing. Good question. Cool. Okay, so pull up this document here, and I'd like you to scroll down to the exercises and spend the next 10 minutes or so working on those. Try to get through at least 1 and 2, and maybe 3 as well. And I'll give you one more. I'll give you one more trick that we didn't really talk about with the times loop, which is that if I need to. Sometimes when you're writing a times loop using like 5.times, you want to be able to access the current number within your block. And the way you can do that is by saying, 5 do, and I can say do I, and then in here we could say puts. So the syntax here is that we put, sometimes people call these the goalposts. We put 2 vertical pipe characters around some variable name, and this is what we call a block variable. So now you can use that I within the scope of your block, and each time the block is executed, it'll have the new value I for what the current number is. So that can sometimes be a handy thing as well. Yeah, I just do all the exercises in IRB. That'll be good. Okay, cool. So work on those for a few minutes. Ping me in Slack if you have questions, and then let's plan to gather back up at about 11:05. I'll send out another link for the next Hangout link, Hangout session, and the supplies that I asked you to grab, get those ready as well, because we'll be using those for the next session. So thanks, everybody. See you in a bit.